Hello everybody, welcome back to section 2.4. We're going to continue discussing some principles regarding some geometry types of problems. And we're going to continue by talking about area. And of course we ask, what is area? Well, we just last saw a video that asked us, what is perimeter? Well, perimeter was the distance around the outer edge of an object, two-dimensional object, one of these shapes for instance. But what is area? Well, area can be defined as following. Area is defined as the amount of space that a two-dimensional object can fill within a given boundary. It's always measured in square units, so it's not the same units as the lengths of the sides. And we know that there are a few formulas that everyone's pretty much used to from geometry, but let's give one here. If we have a right triangle, for example, we have an altitude, which we call h. That'll be the height of the triangle, and of course the base, we'll call that b. And we say that if we have a triangle, the area is equal to 1/2 times the length of the base times the height, which is the altitude as a right angle measured from the base. There's a few more that we know. If we have a square with a length of side s, the area is defined as the square of that side length, which tells us why we might get square units. In fact, a square is almost the way that we think about units. If we have a square with a length of 1 on each side, then it's a unit, a square unit. And we ask how many square units would be able to fit inside of our triangle, or inside of our square, or inside of our rectangle. A rectangle is a figure that has length and width, and so we define the area here to be length times width. Finally, for a circle, it's slightly different. For a circle, we have to have something called the radius. The radius, of course, is the distance from the center to the outer edge of the circle, and many people remember this particular formula as area being equal to pi times r squared. Okay, so the square of the radius times the number pi. Pi is approximately 3.14. We usually use that as an estimate. In fact, it's an irrational number that keeps on going, 1, 4, 1, 5, 9, and a lot of other digits after that. But we just go with, that should be a little dot, dot, dot down there. Let's see. Whoop. Dot, dot, dot. This number keeps on going in an unpredictable manner. It's an irrational value. But we can use 3.14 for our estimates. Okay, so let's use this. Let's say we're asked to find the area of the triangle shown. Well, in this case, using our triangle formula, area equals 1/2 times the base times the height. We're just going to go ahead and substitute in our numbers right here. We're told that the base is 15 centimeters and the height would be 8 centimeters. So let's put that in here. Area is equal to 1/2 times the base, 15 centimeters, times the height, 8 centimeters. And if we take this product right here, area will be equal to, let's see, we can take this multiplication in any order that we want, but in fact 15 times 8 is the same thing as 8 times 15. So if we really want to, we can treat this as 1/2 times 8 times 15, just switch the places of the two factors in our product, and then multiply from left to right. And 1/2 times 8 is equal to 4. And that's 4 times 15. And let's see, 4 times 15, 2 times 15 would be 30, so we'll take twice that. It's going to be 60. But remember that you need to use the correct units, so the correct units here would be squared centimeters. We're multiplying centimeters times centimeters. So make sure that every single time you write out an answer for something like an area, you give it in square units. Now we can use all of this information to solve problems that seem a bit more complex. Like, for example, this last question asks, what is the area which lies outside of the circle with a diameter of 2 inches, but inside the square whose length is 2 inches? So in other words, we're looking for this shaded area. What is it? An area of that shaded area. Well, we know areas of squares. We also happen to know areas of circles. What can we say about this? Well, if we're interested in just that shaded in area right there, it's almost as if we're going to take the area of whatever's inside of our square, and we're going to subtract whatever area is inside of the circle. Right? So we want to take this away. And that's going to get our area of that shaded region with the circle in the center of it removed. Right, so that's going to give us this area around the edge here. I'm kind of trying to diagram this right here. So we have our square. And of course, the area is our squared sides. But we have to take away our circle. What was our circle? Our circle was the one that went pi r squared. All right, so we need to have a radius. We have a diameter of 2 inches. Be very careful. There is a difference between diameter. Diameter is the distance from one edge to the other of the circle right here. But if we're interested in the radius itself will be 1 inch. There we go. So what do we do with that? All right, let's make our substitution. We're going to take the length of our side of our square. Well, each of our squares have a side of 2 inches in this particular case. So if we make the substitution, we're going to say, not negative, just a crazy pen, 2 inches squared. And we're going to subtract away from that pi, which we're going to estimate as 3.14 times 1 squared. All right, let's see what we get when we make these substitutions right here. We're going to be taking 4, and we're going to be subtracting away from that 3.14. Remember that 1 squared is 1. So we're going to take 3.14 times 1. And so our area will be the difference of these two. Let's see if we remember how to do this. 4.00 minus 3.14. Always have to remember to pick up my pen so that the thing doesn't bleed. 1, 4. All right, so subtract. And when we make the subtraction, of course, we can't take away 4 from 0, but we can borrow. 4 minus 1 is going to be 3. Get my pen to work here. 3. Gives us 10, but we take away from that, we get 9. Gives us 10, we take away 4, we get 6. 9 minus 1 is 8. 3 minus 3 is 0. So our area in that shaded region is going to be 0.86. Now once we get that answer, don't forget, of course, the main thing that we will want to remember is that it's not only 0.86. We're being asked about area, so the question was, what is the area which lays outside here? And if this is in inches, we're going to say that our area will equal 0.86. Try that again. 0.86 square inches, which we write inches squared, not ln squared. Leaky pen. Try it again. 0.86 inches squared. There we go. So this is the way that we would express our answer, and we're done.